The Soviet Union spent over 3 billion rubles developing a weapon that could make an entire army disappear. Not through violence, through biology. They called it biopreparat, and by the time Western intelligence discovered its true purpose, the Soviets had already stockpiled enough weaponized anthrax to kill every human on Earth 3 times over. The program was shut down in 1992, officially, but the scientists who built it claim the most dangerous creations were never destroyed. They were simply moved. During the Cold War, both superpowers raced to develop technologies so devastating that using them would guarantee mutual annihilation. These weren't theoretical doomsday devices sketched on paper and filed away. They were built, tested, and in some cases deployed in limited capacity before someone realized the consequences were irreversible. What follows are 10 inventions that crossed a line, tools engineered not just to win wars, but to rewrite the rules of survival itself. Cobalt bombs, the doomsday dust. In 1950, physicist Leo Szilard proposed a modification to the standard hydrogen bomb. Wrap the warhead in cobalt-59, he suggested, and the explosion would produce cobalt-60, a radioactive isotope with a half-life of over 5 years. The result wouldn't just destroy a city, it would render continents uninhabitable for generations. Fallout would circle the globe on atmospheric currents, poisoning water supplies, crops, and breathable air. There would be no safe zones, no shelters deep enough. The United States ran the calculations, so did the Soviets. Both concluded the same thing. A cobalt bomb wasn't a weapon, it was a civilization eraser. You couldn't win a war with it. You could only end the world. And yet, rumors persisted throughout the 60s that the USSR had constructed at least one prototype, hidden somewhere in the Ural Mountains. No documentation has ever surfaced, but the scientists who worked on Soviet nuclear programs have never denied it either. Acoustic weapons, the sound that breaks minds. In 1972, a classified U.S. Navy research facility in San Diego began experimenting with low-frequency sound waves as a crowd control mechanism. The idea was simple: find the resonant frequency of the human body and use it to induce discomfort, disorientation, or compliance. What they discovered was far more disturbing. At certain frequencies below 20 Hz, subjects reported uncontrollable fear, vivid hallucinations, and in some cases, temporary paralysis. One test involved playing a 7 Hz tone in a sealed room. Within minutes, participants began seeing shadowy figures that weren't there. Some claimed the walls were breathing. Others described a crushing sensation in their chests, as if invisible hands were pressing down. The project was terminated after a researcher suffered a psychological breakdown and refused to re-enter the lab. The equipment was dismantled, but the underlying science wasn't disproven. It was classified. The Soviets pursued a parallel track. Declassified KGB documents reference a device codenamed Zombie, designed to transmit inaudible pulses through building ventilation systems. The goal was to destabilize enemy command centers without firing a shot. Field tests allegedly occurred in Prague during the 1968 Soviet invasion, though no official records confirm deployment. What is confirmed? Multiple acoustic research labs across the Eastern Bloc were quietly shuttered in the mid-70s, their findings sealed under national security protocols. Project Plowshare, nuclear excavation. Between 1961 and 1973, the United States detonated over 24 nuclear bombs on its own soil, not as weapons tests, but as construction tools. The Atomic Energy Commission believed atomic explosions could reshape landscapes more efficiently than conventional excavation. They proposed using nukes to carve out harbors, widen the Panama Canal, and even create an artificial sea in the Nevada desert. The first test, Operation Gnome, was conducted in New Mexico. A 3.1 kiloton device was buried 1,200 feet underground and detonated to create a storage cavity for natural gas. The explosion worked as planned. The radiation did not. Venting gases released radioactive steam into the atmosphere, contaminating nearby farmland and water tables. Livestock in the area developed lesions. Cancer rates spiked among workers. Undeterred, the program continued. Project Sedan, conducted in Nevada, used a 104-kiloton bomb to blast a crater over 1,200 feet wide and 320 feet deep. The fallout cloud drifted across 11 states. Milk supplies in Minnesota tested positive for iodine 131. The public was never informed. By the time Plowshare was officially cancelled in 1977, the government had learned a hard lesson. You cannot control a nuclear explosion's byproducts, no matter how deep you bury it. Binary chemical weapons. The two-part death. Standard chemical weapons have one fatal flaw. They're dangerous to store, transport, and handle. A single accident during production or deployment can kill the very soldiers meant to use them. The solution, developed independently by both the US and USSR in the late 60s, was binary munitions. Store two non-lethal chemicals separately. When the weapon is fired or deployed, the chemicals mix mid-flight, creating a deadly nerve agent only at the moment of impact. The US produced the M687 artillery shell, designed to combine two precursor agents into sarin gas during flight. The Soviets developed Novichok agents using a similar binary system. On paper, it was safer. In practice, it was a nightmare. The chemical reactions were unpredictable under varying temperatures and pressures. Some shells failed to mix properly and landed inert. Others mixed prematurely, releasing gas near friendly forces. Worse still, the binary approach allowed nations to stockpile chemical weapon components without technically violating international treaties. The chemicals themselves weren't banned, only the final product. This loophole enabled covert production on a massive scale. By the 80s, both superpowers had enough binary munitions to saturate entire regions with lethal gas. The weapons were never used in open conflict, but that wasn't due to restraint. It was fear. Once released, nerve agents don't discriminate. Wind patterns shift, containment fails, and the side that deploys them often suffers as much as the enemy. What made these inventions too dangerous wasn't just their destructive power. It was their unpredictability, the gap between what engineers promised and what reality delivered. The next set of projects would take that unpredictability even further, into domains where the line between weapon and catastrophe disappeared entirely. Hashtag Part 2 of 2 Project Westford, the Orbital Antenna Belt. In 1961, the US military faced a communications problem. Radio signals traveling across continents relied on ground-based infrastructure vulnerable to sabotage or nuclear attack. The solution proposed by MIT's Lincoln Laboratory was audacious: launch millions of tiny copper needles into orbit to create a reflective belt around Earth. Signals could bounce off this artificial ionosphere, ensuring uninterrupted military communication even if ground stations were destroyed. Operation Westford began that May. A single satellite released 350 million copper dipoles, each about 1.8 centimeters long, into low Earth orbit. The needles dispersed as planned, forming a faint reflective band. Initial tests showed promise. Radio signals successfully bounced off the needle cloud. Then astronomers intervened. The needles weren't just reflecting radio waves. They were scattering light, interfering with telescope observations. International outcry followed. Scientists warned the debris could remain in orbit for years, cluttering near-Earth space and endangering future satellites. The military conducted a second test anyway in 1963, releasing another 350 million needles. Most eventually fell back to Earth, but not all. Decades later, clumps of Westford needles still orbit the planet, tracked by space debris monitoring systems. What seemed like an elegant solution became an early lesson in orbital pollution, one that foreshadowed the satellite graveyard we've built ever since. The sonic boom city tests. Between 1956 and 1967, the Federal Aviation Administration conducted over 1,200 supersonic flights directly over American cities. The goal was simple: determine whether civilians could tolerate sonic booms if supersonic transport became routine. Oklahoma City became the primary test site. 8 times per day, military jets broke the sound barrier overhead. Windows shattered across residential neighborhoods. Plaster cracked. Livestock panicked. Citizens filed over 15,000 damage claims, totaling millions of dollars. The FAA dismissed most complaints, arguing the booms were within acceptable limits. But the psychological toll couldn't be quantified. Residents reported chronic anxiety, sleep disruption, and heightened stress. Children dove under desks at school, conditioned to associate the sonic crack with danger. After 6 months, public pressure forced the program's cancellation. The data collected was clear. Humans could not adapt to repeated sonic booms. The findings effectively killed the American supersonic transport program before it began. What remains troubling isn't just the physical damage, it's that the government knowingly subjected an entire city to daily acoustic bombardment without informed consent. Starfish Prime, the sky that glowed green. On July 9, 1962, the United States detonated a 1.4 megaton nuclear warhead 250 miles above the Pacific Ocean. The explosion was part of Operation Fishbowl, designed to test how high-altitude nuclear blasts affected radio communications and satellite systems. What happened next stunned observers across the Pacific. The sky turned green. Auroras erupted over Hawaii, Samoa, and New Zealand, thousands of miles from the blast site. Streetlights failed across Honolulu. Satellites went dark. The artificial radiation belt created by the explosion persisted for years, disabling at least 6 satellites and damaging dozens more. Scientists had predicted electromagnetic pulse effects, but vastly underestimated their range. The explosion generated a pulse strong enough to fry electronics across an area larger than Western Europe. If a similar weapon were detonated today over North America, the cascading failures could collapse power grids, disable communications, and cripple infrastructure for months. Starfish Prime proved that nuclear weapons didn't need to strike the ground to cause catastrophic damage. The sky itself could become a weapon, and once triggered, the effects couldn't be contained or reversed. The nerve gas leak at Skull Valley. In March 1968, a U.S. Air Force jet released a cloud of VX nerve agent over Dugway Proving Ground in Utah. The test was routine: spray chemical agents, measure dispersal patterns, analyze lethality. But wind conditions shifted unexpectedly. The gas drifted 20 miles east into Skull Valley. Within hours, over 6,000 sheep were dead. Ranchers found entire flocks collapsed in fields, mouths foaming, bodies convulsing. Military personnel in hazmat suits arrived to collect carcasses, refusing to answer questions. The army initially denied responsibility, suggesting the sheep had died from natural causes or contaminated feed. Autopsies confirmed VX poisoning. The military quietly compensated ranchers, but never acknowledged the full scope of contamination. Water samples from nearby wells showed trace amounts of organophosphates. Residents reported unexplained illnesses, tremors, respiratory distress, vision problems, symptoms consistent with low-level nerve agent exposure. The incident exposed a fundamental flaw in open-air chemical testing. You cannot control where the wind blows. Yet testing continued at Dugway for another decade, with only minor adjustments to weather monitoring protocols. The sheep weren't the anomaly. They were the warning. Conclusion: these weren't fringe experiments conducted in secret labs by rogue scientists. They were official government programs, approved at the highest levels, funded with public money, and defended as necessary for national security. Each one pushed the boundaries of what was considered acceptable risk, and each one failed in ways that should have been predictable. What makes these inventions dangerous isn't just their immediate destructive capacity. It's the gap between ambition and consequence, between what engineers promised and what reality delivered. Copper needles that cluttered orbit, sonic booms that terrorized cities, nuclear blasts that turned the sky green and killed satellites for years. The pattern is consistent. Deploy first, measure consequences later. Dismiss public concerns, classify the failures, move on to the next project. The true cost isn't tallied in dollars or casualties alone. It's measured in the lingering contamination, the shattered trust, and the precedents set for future experiments. These projects ended not because leadership suddenly developed ethics, but because the damage became too visible to ignore. The question isn't whether we've learned from these mistakes. It's whether the next generation of weapons, autonomous, algorithmic, invisible, will leave us any evidence to learn from at all. The inventions documented here share a common thread. They were designed to solve immediate tactical problems without accounting for cascading consequences. Cobalt bombs that would poison continents, acoustic weapons that shattered minds, nuclear excavation that irradiated farmland, binary munitions that turned treaties into loopholes. Each project began with confidence and ended in containment. The danger wasn't just in their destructive potential. It was in the arrogance that humanity could control forces we barely understood. We built tools that could break the world, then acted surprised when they did exactly that. The Cold War ended, but the mindset that created these weapons didn't. It evolved. Today's experimental technologies operate in domains even more abstract: genetic code, artificial intelligence, quantum computing. The stakes haven't lowered. They've simply moved beyond our ability to perceive them until it's too late. What history teaches isn't that we stopped building dangerous things. It's that we got better at hiding them.